Hi guys, you all just open Jupyter Notebook. Today I am giving an overview on chi-square distribution and also on ANOVA. Okay, so in the last session we covered non-parametric test. Okay, so this is what we have covered. Okay, we have covered non-parametric tests are more powerful when the assumptions for parametric tests are validated, okay, and can be used for all data types such as nominal, ordinal, interval, and also when data has outliers, okay. And if any of the parametric test is valid for a problem, then using non-parametric test will give highly inaccurate result. So, parametric test have more statistical power because it considers mean. So in that case, if your data is following normal distribution or whatever the assumptions you're taking, then you obviously conduct parametric test and uh, don't go with non-parametric test. But when the assumptions are violated, then you have to consider non-parametric test. So okay, so and these are the some non-parametric tests we did yesterday. That one is Mann-Whitney test. It is used for testing the difference between two independent groups with ordinal or continuous dependent variable. Okay, so two independent groups. Okay, this is the alternative of independent sample t-test. Okay, and the your output, that is the dependent variable, may be ordinal or continuous. Okay, Wilcox and Sine rank test, that is used for testing the difference between two related variables, which takes into account the magnitude and direction of difference. However, Sine test ignores the magnitude and only considers the direction of the difference. Kruskal-Wallis test compares the outcome among more than two independent groups. More than two independent groups. Okay, so this is something uh, related to parametric test one way ANOVA, but when the assumptions are violated, we better, and the sample size is too small, then we consider Kruskal-Wallis test. Okay, so here just look, we just compare this more than two independent groups by making use of their medians. Okay, and Spearman rank correlation is also a technique. We have already covered the correlation part, so Spearman rank correlation coefficient. So that is also a non-parametric alternative. Okay, and this is used to check if there is a relationship between the two data sets, and it also tells about the type of relationship, that is whether positively directed or negatively directed. Okay, just wait. Just wait 1 minute. My internet is not stable. Okay. So look, what I have told you, that is this Spearman rank correlation coefficient is also an alternative to Pearson's correlation coefficient. It is a non-parametric. This Spearman rank correlation coefficient is a non-parametric test where ranks are considered to deduce in the formula to deduce the value of the row. Okay, and so that's it for the non-parametric test. Now we come to chi-square statistics. So what does what does it do, and what sort of distribution is called to be as chi-square distribution? Okay, so just do one thing. You just go through what is chi-square. Go through. Expectations compared to results. Okay, this means a chi-square statistic is a measurement of how expectations compared to results. What do you mean by that, Ujjal? What do you mean by that? Ujjal, what do you
Yes.
mean by that?
Expectation is nothing but the outcome that we are expecting, and
Hmm.
compared to the results means what is the output.
Okay, so results is your observed values, and expectations your the expected frequencies. Okay, what is expected output? Okay, that is suppose something you have decided that something if you have deduced theoretically, and but in practice you have got some different output. Okay, so whatever you are getting in practice, that is your observed values, and whatever you have deduced theoretically, that is your expected frequency. Okay, expected values. Okay, so these so it will just compare these expectations to the observed values. Okay, so the data used in calculating chi-square statistic must be random. Okay, raw, mutually exclusive. Okay, drawn from independent variables, and drawn from mutually exclusive means drawing one sample does not affect the other, there is no common part. Okay, so drawn from independent variables and drawn from a large enough sample. Okay. Okay, so for example, the resulting results of tossing a coin 100 times meets this criteria. Okay, now look at this. This lesson explains how to conduct a chi-square goodness of fit test. Okay. So this lesson explains how to conduct a chi-square goodness of fit test. Okay. The test is applied when you have one categorical variable from a single population. Okay. It is used to determine whether the sample data are consistent with the hypothesized distribution. Okay, whether the sample data are consistent with a hypothesized distribution. Okay, for example, suppose a company printed baseball cards. It claimed that 30% of its cards were rookies, 60% veterans, and 10% all-stars. Okay, we could gather a random sample of baseball cards and use a chi-square goodness of fit test to see whether our sample distribution differed significantly from the distribution claimed by the company. Okay. So the sample problem at the end of the lesson considers the example. When to use the chi-square goodness of fit test. The chi-square goodness of fit test is appropriate when the following conditions are met. Okay, look at the condition. The sampling method is simple random sampling. The variable under study is categorical. The expected value of the number of sample observations in each level of the variable is at least 5 in each level. Okay, that is for veterans, for all stars, and for rookies. Okay, these are the three levels now. So for these three levels, at least the expected value of the sample observation, whatever sample you are drawing out from the population, will have at least 5 members. Okay, in each group, that in each level. Okay, so this approach consists of 4 steps: stating the hypothesis, formulating the analysis plan, okay, analyze the sample data, interpreting the results. So how can we do that? Look, so state the hypothesis. Every hypothesis test requires the analyst to state a null hypothesis and an alternative hypothesis. Okay, go through again. Every hypothesis test requires the analyst to state a null hypothesis and an alternative hypothesis. Okay, so the hypotheses are stated in such a way that they are mutually exclusive. Okay, that is, if one is true, the other must be false, and vice versa. Okay, they don't have any common part. Okay, they do not influence each other. Okay, so if one is true, other must be false, and vice versa. If the other is true, then the first one is false, like that. For a chi-square goodness of fit test, the hypothesis takes the following form. The date in the null hypothesis, it is written the data are consistent with the specified distribution, and in the alternative hypothesis, the data are not consistent with the specified distribution. What is the specified distribution? The company claimed that 40% cards are rookies, 60% are veterans, and 10% All-Stars. So we have to prove that. Okay, so typically the null hypothesis specifies the proportion of observations at each level of the categorical variable, and the alternative hypothesis is that at least one of the specified proportions is not true. At least one of the specified proportions is not true. Okay, now formulating an analysis plan. Look at that. The analysis plan describes how to use sample data to accept or reject null hypothesis. The plan should specify the following elements. First, significance level. Often researchers choose significance level equal to 0.01, 0.05, 0.10, but any value between 0 and 1 can be used. Okay. Test method is your second element. Use the chi-square goodness of fit test to determine whether observed sample frequencies differ significantly from expected frequencies specified in the null hypothesis. The chi-square goodness of fit test is described in the next section and demonstrated in the sample problem at the end of this lesson. Okay. So what are those? We will come to that part later. Now look at how we can analyze the sample data. Using sample data, find the degrees of freedom, expected frequency counts, test statistic, and the p-value associated with the test statistic. So degrees of freedom is equal to the labels, number of labels of the categorical variable minus 1. Obviously, 1 is compromised. If you know the rest, if you have 4 labels, and if you know the 3 labels, if you set 3 labels, so 4th level will be determined. Okay, so this is the reason that the number of independent labels that are free to vary here is k minus 1. That's why the degree of freedom is k minus 1. Now expected frequency. counts. The expected frequency counts at each level of the categorical variable are equal to the sample size times the hypothesized proportion from the null hypothesis. So EI equal to N into PI. N times N is your sample size, N times the hypothesized proportion from the null hypothesis, so N into PI, where EI is the expected frequency count for the ith level of the categorical variable, N is the total sample size, and Pi is the hypothesized proportion of observation in level I. Okay. Now test statistic. Test statistic is a chi-square random variable. Okay. The chi-square defined by the following equation. Okay. So chi-square is summation of OI minus EI whole square by EI. Observed frequency at eye level, observed values at eye level minus expected frequency or values at eye level get squared, and that needs to be divided by the expected frequency, and you have to take total summation, okay, of that. So Y is your observed frequency count for ith level of the categorical variable, and EI is the expected frequency count of the ith level of the categorical variable. Okay. So p-value is the probability of observing a sample statistic as extreme as the test statistic. Since the test statistic is a chi-square, use the chi-square distribution calculator to assess the probability associated with the test statistic. Okay. So here use the degrees of freedom that is computed above. Okay. So how can we interpret the results? If the sample findings are unlikely given the null hypothesis, the researcher rejects the null hypothesis. Typically, this involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. Okay. So test your understanding problem. There is a problem which you have to do. Okay. Acme Toy Company. Okay. Prince baseball cards. Okay, the company claims that 30% of the cards are rookies, 60% veterans, and 10% all stars. Now, suppose a random sample of 100 cards has 50 rookies, 45 veterans, and 5 all-stars. Is this consistent with Acme's claim? Use a 0.05 level of significance. The solution to this problem takes 4 steps. First is stating the hypothesis. Second is formulating an analysis plan. Third is analyzing sample data. And fourth is interpreting the results. Okay, so we work through these steps below. Okay. And look, stating the hypothesis, the first step is to state the null hypothesis and an alternative hypothesis. The proportion of rookies, veterans, and all stars is 30, 60, and 10% respectively. At least one, an alternative hypothesis is at least one of the proportions in the null hypothesis is false. And how to formulate an analysis plan? For this analysis, the significance level is 0.05. Using sample data, we will conduct I-square goodness of fit test of the null hypothesis. Now, how to analyze the sample data? Applying the chi-square goodness of fit test to sample data, we compute the degrees of freedom. Okay. The expected frequency counts and the chi-square test statistic. Okay, based on the chi-square test statistic and the degrees of freedom, we determine the p-value. Okay. Now degree of freedom is k minus 1 equal to 3 minus 1 equal to 2. 3 groups now, rookies, veterans, and all stars. Okay, so expected frequency is n into pi. So these are the, for E1 it is 100 into 0.30. Okay, for E2 100 into 0.60, because veteran, the proportion of veterans is 60%, and and for all stars the proportion is 0.10, so E3 equal to 100 into 0.10. This is how we calculate, because 100 is your sample size. Okay, so what is your chi-square? Look, I-square is 50 minus 30 because it is mentioned. Look, a random sample of 100 cards has 50, that is your observed values, 45 veterans and all, 50 rookies, 45 veterans and 5 all-stars. Okay, so these are your observed values. So when you are computing chi-square, 50 minus 30 whole square by 30, 45 minus 60 by 45 minus 60 whole square by 60, and 5 minus 10 whole square by 10. Okay, so this will ultimately give you 19.58. Okay, where degree of freedom is the degrees of freedom, k is the number of labels of the categorical variable, n is the number of observations in the sample, here is the expected frequency count for label I, OI is the observed frequency count for label I, and chi-square is the chi-square test statistic. Okay. So the p-value is the probability, okay, that a chi-square statistic having 2 degrees of freedom is more extreme than 19.58. Okay, so we use the chi-square distribution calculator to find p of I-square greater than, that is probability of square greater than 19.58. 19.58 is equal to 0.0001. So now we have to interpret the result. Since the p-value is less than the significance level 0.05, we cannot accept the null hypothesis. That means we reject the null hypothesis. Okay, since the p-value is less than the significance level 0.05, we reject the null hypothesis. Okay, so the distribution is not, so we can conclude that, go back to the hypothesis part where the hypothesis I mentioned, we conclude that at least one of the proportions in the null hypothesis is false. Okay. Now look at the chi-square test for independence or homogeneity. Okay. Okay, so I'm giving you 2 minutes to go through. Okay, then I will explain. Okay, so in the given in the previous one we have in the previous topic we have covered the word that is chi-square test for goodness of chi-square goodness of fit test. Okay, so look at that. Chi-square goodness of fit test, where we consider only one categorical variable and the distribution of that categorical variable, whether it follows the proportion according to the company is claiming, that is suppose whether it follows some given distribution, say that is mentioned in the null hypothesis, that is the whether the sample data are consistent with the hypothesized distribution. That hypothesized distribution may be a normal distribution, so the sample, whether the sample data are consistent with that the normal distribution or with the hypothesized distribution what the company is claiming. Okay, or they are not following at least one of the proportion is at least one of the proportion. Look at this part. At least one of the proportion in the null hypothesis is false. That means what? Just go back to this part. That is, the data are not consistent with the specified distribution. When one of the proportion is not true, okay, then what does it mean? That means the data are not consistent with the specified distribution. That is what the sample statistic tells about the population. Okay, here we are considering the proportion. Okay, so according to the when you want to make some statement on population proportion, then that sample statistic, that is chi-square statistic here is used, which will ultimately give you either either the acceptance of null hypothesis, that is we cannot reject the null, we fail to reject the null, we retain with the null, or we reject the null. That is the alternative statement becomes true, that is the data are not consistent with the specified distribution. Okay, so that is what we have dealt with one category for different levels of one categorical variable. The categorical variable may have different levels, okay, but the proportions of that categorical variable is considered here. Okay, to test the chi-square goodness of fit test. Okay, now the thing is that when we come to learn about the chi-square test for independence or homogeneity, then you have to consider more than then you have to consider two categorical variable. Okay, so this test is applied when you have two categorical variables from a single population. Okay, it is used to determine whether there is significant association between these two variables or not. Okay, for example, in an election survey, voters might be classified by gender and voting preference. Okay, so we could use a chi-square test for independence to determine whether gender is related to voting preference or not. Okay, so the sample problem at the end of the lesson considers this example. Okay, so when to use chi-square test for independence? Okay, the test procedure described in this lesson is appropriate when the following conditions are met. The sample method is simple random sampling. The variables under study are each categorical. If sample data are displayed in a contingency table, the expected frequency count for each table cell of the table, that is for each table of the table, is at least 5. Okay, so this approach consists of 4 steps: state the hypothesis, formulate an analysis plan, analyze sample data, and interpret results. Look at the conditions. The conditions for goodness of fit test and the chi-square test for homogeneity or independence are same. Look, the expected value of number of sample observations in each level of the variable is at least 5. The sampling method is random sampling. The variable under study is categorical. The assumptions remain the same. Okay, only the implementation is different. Okay, in case of chi-square test for independence or homogeneity. Okay. So look, this approach obviously also consists of four steps. First one is state the hypothesis. Second, formulate an analysis plan. Third is analyzing sample data. Fourth is interpreting the results. Okay. So just look at how to state the hypothesis. Suppose that variable A has R levels, B has C levels. The null hypothesis states that knowing the level of variable A does not help you predict the level of variable B. That is, the variables are independent. So variable A and the variable B are independent. And in alternative hypothesis, variable A and variable B are not independent. Okay. That is, the levels of variable A have an influence to the level of variable B. That is what has been mentioned in your alternative hypothesis. Okay. So the alternative hypothesis is that knowing the level of variable A can help you predict the level of variable B. Suppose for the alternative hypothesis suggests that the variables are related, but the relationship is not necessarily causal in the sense that one variable causes the other. Okay. That is, in some cases one variable can maybe the cause of the other, but it may also happen that the relationship is not necessarily causal. That is, if the one variable is not the cause of the other. Okay, causal means whether the causal is used in the sense that one variable causes the other, but it may not be the case always. There may be relationship exists between two variables, but that may be not due to any cause result oriented. That is, the relationship is not necessarily causal. Okay. Now come to that part where we need to learn how to formulate an analysis plan. So the analysis plan describes how to use sample data to accept or reject null hypothesis. So you have to specify two elements here. First, your significance level. Okay. Second is your test method. Okay. Have you all gone through? Ujjal, what you have understood? Ujjal, what you have understood?
Yes, ma'am.
What you have understood?
Yeah, I'm going, ma'am. Just 2 minutes, ma'am.
Yes, yes.
Ma'am, here they are explaining like the steps to accept or reject the null hypothesis, like how to use the sample data to accept it.
But what do you have to determine? Through
Like, ma'am, we have to determine the degrees of freedom and also the frequencies and p-value.
That are used to compute the chi-square statistic. But chi-square statistic determines what? That is used
Relation.
to at this part. That is used to determine whether there is a significant relationship between two categorical variables. Which two categorical variables in the given example? That is your gender and voting preference. Okay.
Yes.
These are the two input variables which are categorical by nature. Okay, so you have to know, you have to find out whether there is significant relationship exists or not. Okay, that's why you have to conduct chi-square test for independence or homogeneity. Okay, and for that how to how to formulate your plan, that is analysis plan. You have to choose significance level, that is you can choose between you can choose any value between 0 and 1, that is 0.01, 0.05 or 0.10, and you have to determine the test method, that is chi-square test for independence is used here. Okay, now come to this analyze sample data, that is using the sample data find the degrees of freedom, expected frequencies, test statistic, that is chi-square statistic, and the p-value associated with that with the test statistic. Okay, so the approach described in the section is illustrated in the sample problem at the end of the lesson. Okay, so we will look into that. Look at the degrees of freedom here. In the previous one, we have found out the degrees of freedom to be k minus 1. Okay. But here, that is k is your number of levels. So k minus 1 will be your degrees of freedom in the chi-square goodness of fit test. But look here, it is r minus 1 times c minus 1, where r is the number of labels of one categorical variable and c is the number of labels for the other categorical variable. Because if you if your categorical variable a has r levels, and if your categorical b has c levels, so r minus 1 will be the degrees of freedom when you are considering only a, and c minus 1 will be the degree of freedom when you are considering only b categorical variable. Okay, so how many combinations you can find out? R minus 1 multiplied by c minus 1, so r minus 1 times c minus 1, that is your degrees of freedom. Okay, understood? Now come to the expected frequency. The expected frequency counts are computed separately for each level of one categorical variable at each level of the other categorical variable. Okay. Compute R into C expected frequency according to the following formula. Look, E R comma C, that is your cell for a given row and particular column. Okay, that will be NR into NC by N. So ERC is the expected frequency count for level R of variable A and level C of variable B. N is the total number of sample observations at NR is the total number of sample observations at level R of variable A. Okay, and NC is the total number of sample observations at level C of variable B, and N is the total sample size. Okay, so now how do you compute the test statistic? The test statistic is a chi-square random variable. Okay, defined by the following equation. Okay, look at the equation. The equation is just gets tensed at the suffix levels O r comma c and minus e r comma c. Okay, and so where ORC is the observed frequency count at level R of variable A and level C of variable B, and ERC is the expected frequency count at level R of variable A and level C of variable B. The p-value is the probability of observing a simple sample statistic as extreme as the test statistic. Okay, since the test statistic is a chi-square, okay, we use the chi-square distribution calculator to access the probability associated with the test statistic. Okay. So you use the degrees of freedom computed above. Okay. So interpret the results. If the sample findings are unlikely given the null hypothesis, the researcher rejects the null hypothesis. Typically, this involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. Okay. So now we have to test our understanding. So look at the problem with some given values. Okay. A public opinion poll surveyed a simple random sample of 1000 voters. Respondents were classified by gender, male or female, and by voting preference. Results are shown in the contingency table below. Okay. So, is there a gender gap? Do the men's voting preference differ significantly from the women's preferences? Okay. So, use the 0.05 level of significance. Okay. Solution to this problem takes 4 steps. State the hypothesis, formulate an analysis plan, analyze sample data, and interpret the results. We walk through these steps below. State the hypothesis. The first step is to state the null hypothesis and an alternative hypothesis. In the null hypothesis, it is given the gender and voting preferences are independent. And in alternative hypothesis, the gender and voting preferences are not independent. Okay. For this analysis, the significance level is 0.05. Using sample data, we'll conduct a chi-square test for independence. And how to analyze the sample data? Applying the chi-square test for independence to sample data, we compute degrees of freedom, the expected frequency counts, and the chi-square test statistic. Based on chi-square statistic and the degrees of freedom, we also determine the p-value. So look at the degree of freedom r-1 into c-1. So your r, that is gender, has 2 levels. So 2 minus 1 is your r-1. Male and female, 2 minus 1. Okay. And voting preference are 3. Republic, Democrat, and Independent, 3 minus 1. So 2 minus 1 into 3 minus 1, that becomes what? That becomes 2. So now you have to compute the expected frequency at each level, at each r level of variable A and c level of variable B. Okay. So this is E11, 400 into 450 by 1000. Look. E11 means male Republican. Okay. So 400 this is your this level into 450. Okay. So you have to compute this expected frequency of this. So 400 by 450. This is your row total for this level, male. Okay, this is your column total for this for the level, okay, for the Republican level belonging to the categorical variable voting preference. Okay, so 400 into 450 by Look at this. 400 into 450 by total sample size, that is 1000. Look, this is your total 1000. Okay. Now, in this way, we move on. E12, E13, E21, E22, E23. Okay. This way you have to move on. Now compute the chi-square. So this is your first cell value 200 minus 180 whole square 180, then come this, so that is 150 minus 180. Look, this is your E1 to 180, E1 to 180. Okay, and if you go back to the observed one, your E1 to is 150. So obviously this will be 150 minus 180 whole square by 180. In this way, you have to move on and add all those values of the corresponding expected frequencies of the difference between observed and expected frequencies whole square by expected frequency, and summation of these to compute the chi-square statistic, and that is that, and what value you are getting here is 615.2. Now where degree of freedom is no, you know, where DEF is your degrees of freedom, R is the number of levels of gender, C is the number of levels of voting preference, NR is the number of observations from level R of gender, and C is the number of observations from level C of voting preference, and is the number of observations of sample. ERC is the expected frequency count when gender is level R and voting preference is level C. Okay. So, and ORC is the observed frequency count when gender is level R and voting preference is level C. Okay. So the p-value is the probability that a chi-square statistic having 2 degrees of freedom is more extreme than 16.2. We use chi-square distribution calculator to find probability of chi-square greater than 16.2 equal to 0.0003. So now we have to interpret the results. Since the p-value is less than the significance level 0.05, we cannot accept the null hypothesis. That is, we reject the null hypothesis. Okay. Thus we conclude that there is a relationship between gender and voting preferences. Okay. So what does it actually mean? It means that, go back. It means that, look at this, is that the alternative hypothesis is that knowing the level of variable A can help you predict the level of variable B. That means if you know the variable, if you know the level of variable gender, okay, that is, there are 2 levels, the male and female, it will help you predict the level of variable B. That is, it will help you predict the level Republic, Democrat and Independent of variable voting preference. Okay. So then the levels of categorical variable gender has an influence in predicting the levels of categorical variable voting preference. Understood? So this is what chi-square statistic is. Now I am sharing the notebook. Okay, so just open that part. Have you all got this file, digestive biscuits, or not? I think I have not sent. Will you open this snippet of codes? Ujjal, Shima,
And ma'am,
you all have done this thing?
no, you have not shared this file, ma'am.
You all wrote, na? You all jotted.
Not shared.
Huh?
This file is not shared with us.
No, you all jotted down now this snippet of code. That is what I am asking.
Yes, ma'am. Stats
Oh.
demo have written it.
Yes, you all have written it. So open that. You have to run it again. Okay. Then I will explain you. And I am also sending the file. Just wait. Have you all received? Have you all received?
Ma'am, you also shared yesterday this file.
No, no. Digestive biscuits. I have not shared. I have shared blood pressure and genotype.
No, ma'am, this also shared.
So I shared in the second last session. Okay. Not yesterday.
Okay.
Ujjwal, have you got it? Or
Yes, ma'am.
did you have it with you?
That 6 files actually in that I think so it is there, ma'am.
Okay. So just run this code. Look. You have to run. Look, this is your summary of this categorical variable. Okay. So you use cross tab method to create the contingency table of diet and cracker. Okay. So if you print this cross tab, okay, this is your cross tab test results, expected frequencies. Okay. So this is proportions of the cell wise. Okay. And if you print this, just look at this out, look at the output. Look, this is your record. Okay, that okay.
Screen is not visible.
Oh, sorry, I have not shared. Look, this is cross tab. Okay, and then we use contingency table using this cross tab. Okay. Look. Test results expected. This is your expected value. Okay. This is your p square chi-square statistic. Okay, p value 0.0, Cramer's V, Cramer. Okay. Okay, so you have just for the you just look at the value. This is your chi-square statistic. Okay, and this is your p value. Cramer's V is a measurement. Okay, so you can say it is a measure of association between two nominal variables. Okay, so it will give a value between 0 and 1. 0 means no association. Okay, and 1 means complete association. Okay, when you reach 1, that means each variable is completely determined by the other. Okay, so that is what Cramer's V suggests. Okay. Now p value is less than the alpha level, say 0.05, so you reject the null. Okay, so okay, I just open that file, the digestive discuss, then you can understand. I'm sharing the I'm sharing my screen to show you the file. Okay, look, we have the we try to find out whether this cracker and diet are independent or not. You can choose others, subject cracker, and okay, and also the bloat and cracker, because bloat and cracker both are categorical variables. Only this digested part is a continuous variable. Okay, so you can choose, you have to find out the categorical relationship between, like you can choose diet and bloat. Okay, you can choose subject and bloat, you can choose cracker and bloat. Okay, so you can choose different types of independent categorical variables to find out the relationship between them. Okay, and use chi-square test statistic for independence or homogeneity between these different categorical variables. Obviously, considers two at a time. Okay. Uh, so on consider two categorical variables at one go to conduct this chi-square test statistic for independence, and just don't consider this continuous variable digested. Okay, so that's what I am saying, and that's what you have to do when you do practice. Okay, because here only diet and cracker have been taken. Okay, now we come to ANOVA part. Before doing that, I give a little bit who is going to join. Okay, someone is going to join. Let him join. Okay.
No, ma'am, it's me only. Actually,
Oh,
the voice is breaking in my laptop,
you're
so I
joining
joined.
from mobile.
Yeah, ma'am, because
From
the
mobile.
voice is breaking in laptop, so I also joined from mobile.
Okay, you can join on mobile. No issues. Hmm. Yes.
Ma'am, screen is not visible.
Yes, I know. I have not shared my screen. Don't worry. When I share, I will let you know. Okay. Do one thing. You have all jotted down this code, na? This snippet of code in the second last session.
Yes, ma'am.
Yes. Have I sent you this file, customer care?
Yes, ma'am.
Okay. So now take down from this. Okay, from 51st line. Okay. Take down. Okay. Okay. Okay, just wait. I am sending you the file first. Have you all received the file?
Yes, ma'am.
Okay. Okay, now go. Now just jot down. Can you all see?
Yes, ma'am.
Done.
Yes, ma'am.
Now take down this. Have you all jotted down this one? Have you all jotted down this one?
Yes, ma'am.
Shima? Punita?
Yes, ma'am.
Yes, ma'am.
Now take down this. 53rd and 54th line. Okay. Done. 53rd line. Done 53rd line. Shima, done 53rd line.
Yes, ma'am.
Ujjwal, done 53rd line. Ujjwal.
Yes, ma'am.
So done 54th line.
Last
No,
line.
ma'am.
Okay. Check. Time.
Done, ma'am.
Take down 55th and 56th line. 54th line is done now, everybody. Everybody has done up to 54th line.
Yes, yes.
Yes,
Okay.
ma'am.
So take down 55th and 56th one. The right part is also given in the second line, that is in the 56th line. Okay, wait, tilt sign. This is tilt sign. Okay, and this is what you have to write in this 55th line for res dot turkey underscore hsd. Okay.
Ma'am, please show the right side.
Hi, what's happened?
Ma'am,
What
from
has
right
happened?
side.
Hmm?
Move your cursor from right side, please, ma'am. Yes, ma'am.
Done?
Yes, ma'am.
Fifty-sixth line done. How
Yes,
many of
ma'am.
you done 55th?
Ma'am, right side is left.
This one.
Yes, ma'am.
Done. 56th line.
Yes.
Yes.
Take down 57th line. Done. 57th line. Done.
Done, ma'am.
Take down 58th line. Done. Done.
Yes, ma'am.
Done. Guys, done.
Yes, ma'am.
50. Ujjwal, done. Punita, done.
Yes, ma'am.
Ujjwal. Okay. Have you got the same output?
Yes, ma'am.
Okay. Now take down this 59th and 60th line. Take down 59th and 60th line. Okay. Done?
Yes, ma'am.
Yes, ma'am.
Punita, Jal, done?
Yes, ma'am. Done, ma'am.
Yes, ma'am.
Okay. Okay, before discussing this another part, I have to let's try. Okay, this is something related to one proportion jet test. Okay, when I talked about hypothesis and tests, then different tests of hypothesis, then I cover jet test, t test, proportion test, but you have to learn a little bit more about it. Okay, that is what is one proportion jet test. Okay, in Python. So look, to perform a one proportion jet test in Python, we use the proportions jet test underscore jet test function from the stats models library. Okay, so this is your counts, nob, a number of observations. Nobs stands for number of trials. Okay, value is your the hypothesized population proportion. Alternative, you can choose two-sided, greater or less, whatever. Okay, two-sided for two-tailed hypothesis test. Okay, so look, the number of success. Okay, count is your the number of success. Okay, the function returns a jet test statistic and a corresponding p-value. So the following example shows how to use this function to perform a one proportion jet test in Python. So what is that? Look, suppose we want to know whether or not the proportion of residents in a certain country who support a certain law is equal to 60% or not. Okay, so we're talking about the proportion. Okay, who support a certain law is equal to 60% or not. So to test this, we collect the following data on a random sample. P0 is your hypothesized population proportion. Okay, hypothesized population proportion. Okay, that is 0.60. So residents who support law is 64. Okay, now sample size is 100. Okay. So out of 100, you have considered that 64 is your 64 is the number of person who support this law. Just wait, my internet is quite unstable. Now look at this. So the following code shows how to use proportions underscore j test functions to perform a fun sample j test. Okay, so look, this is your proportion j test. Pass the number of success to the count parameter, that is 60. Number of observations for the sample is 100, and value, that is hypothesized population proportion is 0.60. That is your number of success. P0, that is the value of the count parameter, and value is the number of persons supports the law from in the given sample size, that is 64. Okay, so it will give you the statistic value along with the p-value. Okay, so look, from the output we can see that you have to run this. Okay, you have to run this snippet of code on your notebook. Okay, and after running you have to check the corresponding values. Okay, the value of the test statistic and the associated p-value as well. So from the output we can see that the jet statistic is minus 0.8165 and the corresponding p-value is 0.4142. Okay, so since this value is not less than alpha equal to 0.05, so we fail to reject the null. we cannot reject the null. We fail to reject the null hypothesis. We do not have sufficient evidence to say that the proportion of residents who support the law is significantly different from 0.60. Okay. So you can use this sample statistic to estimate and assured or written with the null that yes, there are 60% person who support this certain law in that particular country. Okay, it is not different from the population proportion 0.60. Okay, understood? This is how this proportion test is conducted. Okay. So today I am also taking one session at 9 p.m. when we discuss about different types of ANOVA and different and how to use ANOVA and how to interpret as well. So right now I don't want to continue. So Anish, you can stop recording. Anish, are you there? You can stop recording, Anish. Okay, I've messaged you, Anish. Please check if you are there.